Alrighty, here we go. We're rounding out this module in our experimental probability unit. And so here's what you need for today. You need your book, and I need you to open that to page 387. You need something to write with, duh. And make sure you have a calculator handy. That'll help you because in finding probability, most of the time, I must say, we'll probably write it as a fraction, but we also convert them into decimals and percents, and it's just easier to have that tool handy. All right. So what we're going to talk about today is, all right, we've been doing this experimental probability, and so how do we use this to make predictions about events that could happen in the future? All right. Now, the nice thing about today is you kind of have a choice as to how you want to tackle the problem, depending on what way you like to work with. So here's what I mean. If you've ever gone any place and played a traditional dartboard, okay, here's this particular situation in example 1. They say Danae found that the experimental probability of her making a bullseye was about 2 out of 10 or 20%. Wow, in all honesty, that's really hard to hit the bullseye. So 20%, that's her experimental probability. So they're asking you, if she had 75 throws, what is our estimate that is going to be her number of bullseyes out of those 75 throws? So you have two ways you can go about this. One is using proportion way. And when I say that, then you're going to stick with the fraction 2 out of 10. Okay, so 2 bullseyes out of 10 tries will equal, I don't know how many bullseyes out of 75 tries. There's your proportion, and you can go ahead and use cross products. 2 times 75. Cross products are equal to each other. Divide by 10. Boom, these numbers are very nice because I can pretty straightforward solve. I might not even have to grab my calculator to end up with 15 bullseyes there. Okay, if you're familiar with proportions, that's the way you like to solve these kinds of problems. That's what makes it most comfortable for you. Well, by all means, then I want you to tackle it that way. All right. However, those of you that like to use percent and say, hey, 2 out of 10 is 20%. Well, I'm going to solve it that way. And I'm going to say 20% times those 75 throws and figure out what that is. All right. Now, they happen to take that 20% and turn it into a decimal. You have a calculator. You could plug in the percent sign as well. But you basically end up with 15 bullseyes is our estimate for her prediction. Okay, as to how many bullseyes. All right, so you grab this one. On the bottom of this page, it says a car rental company sells accident insurance to approximately 24% of its customers. Okay, stop right there. The minute you see 24%, either you're thinking 24 out of 100, or you're thinking 24%, or if you're a decimal person, maybe you're thinking of 24 hundredths. Okay, all of those are the same thing. Out of 50 or 550 customers, about how many customers are predicted to purchase? If you like proportion way, you'd say 24 out of 100 equals how many out of 550? Solve it from there. If you like percent way, you'd say take 24% times 550 and solve from there. Or if you'd rather just bypass that whole percent key business and take 24 hundredths times 550 directly, you can do it that way. Okay, when we plug this one in, regardless of which way you go about solving it, you should get approximately 132 customers. That's our prediction. Okay, pretty straightforward, I'm telling you. Okay. All right, now they're saying, how can you use this information to make what they call a qualitative prediction? So let's take a look at the next page at example 2. Okay, they say in this doctor's office, they record data and they conclude that on average, 11% of the patients call to reschedule their appointments during the week. Yikes. So the office manager predicts that 23 appointments are going to get rescheduled out of the 240 total appointments. By saying qualitative, they're saying, is that prediction reasonable given the statistics or the data and information you have? So here's what I would do. I'd say, well, let's figure out what 11% of 240 is. Okay, if you like proportion way, that's how you'd set it up. If you like percent way, you'd either take 11% times 240, or if you're a decimal person, you'd convert it to 1100ths times 240. And regardless of whichever method you use, you end up with an answer of 26 4/10. Okay. Office manager had this prediction, 23. Our estimate or our prediction is 26 4/10. The question is her prediction, the office manager's prediction, reasonable? Well, 23 is pretty close to 26.4. So we could say, yes, it's reasonable, although it's a little lower than our prediction. We predict it would be a little higher. That's the part where they're talking about you're going to add some quality to your mathematical prediction. Okay? So here's the second part of this. We're talking about the number of people. And so when you get an answer that's got a decimal in it, it's asking you, does 26 4/10 make sense when we're talking about the number of patients, which is people? And you should say, no, we need whole numbers when we're talking about people. When describing humans or people. So in this case, I would say it would be best to round your number and round it the way it's suggesting. If it's 26 4/10, that 4/10, we should round that then down to 26. Okay? That would be smarter. All right, I want you to test and try this one. So go ahead and feel free to read through this, pause the video for a little bit, grab your calculator, and figure this one out. All right, pause and come back and join me when you think you're ready. All right, 3% of the emails. A total of, oh my goodness, 12,372 emails. Ignore my little blob there. Okay. He is predicting he's going to get 437. We need to take our experimental information, that 3%, or if you like decimals, 0.03, or if you prefer proportion way, take 3/100ths equals how many out of 12,372. Yikes, yikes, yikes. Okay. What do you get? I got 371 1600ths. Okay. Now hold your horses. Let's take a look here. His prediction was 437. It says, do you agree with this prediction? Man, I'm going to say no. He is higher than our prediction, or maybe you want to say my prediction. of, and now here's the thing, we're talking about emails. Emails are what we would consider something called a discrete countable item. You can't have part of an email. Either you get an email or you don't. And so when you count them, you use whole numbers. So I'm going to round this, then our prediction of 371 emails. Okay. So there are a couple things you need to do to add quality to describe your answer versus someone else's prediction. Alrighty? Cool. Get it? Got it? Good. All right. That next page gave you an example to walk through if you need some sort of reference. Let's do one more together here and then I'll turn you loose. All right. Go ahead, pause the video, read through it, and see what you come up with compared to what I come up with. 24% buy 2 or more pairs of shoes. That would be me. All right, so I have 24%. 350 customers came through. So I'm going to calculate using this data what my number would be. All right. Their manager, or actually what they got was 107. So as we're predicting, we're going to take 24% of that 350. This tells me about 84 customers are going to come in and do some big shopping and buy 2 or more pairs of shoes. What actually happened was 107 customers bought more than 2 pairs. So what their question is here is that did more customers buy more than did more customers than normal buy 2 or more pairs of shoes? Okay. My calculation said we would have predicted 84. So definitely 107 is more than our prediction of 84. So it was much higher. It must have been maybe a rainy weekend. Everybody decided to go shopping then. All right. Cool. All right, I'm going to turn you loose on your assignment. So let's take a look here. All right, starting on page 390, you can work through all of those. And then 391, get 1 through 11, and then that last page. All right, so let's do this. I want you to do, starting on this page, from 390 to 392. Go ahead and tackle 1 through 13. Read through those, figure out what they're asking you to do. It's usually a computation with the data and then maybe comparing it with what the prediction might be or what actually happened. All right. As always, good luck and may the force be with you.